Hello, this is Carl Freund again with Cambrian-AI Research. And once again today, I have a very interesting company to chat with you about. And I have two members of the leadership team of that company to explain their technology and their strategy and where they're going. The company is Gray Matter Labs. And we've written a recent research note on this on our website. Check it out. With me today is Mahesh Makajani, who is the VP of Business Development and Marketing, and happy to have Ingolf Held, who is the CEO of the company. Welcome, guys.
Nice to meet you.
Thanks for having us.
My pleasure. I've been looking forward to this. So let's just start at a high level. Ingolf, tell me about Gray Matter Labs. What is it you guys are doing? What's the mission of the company? And briefly, what's the status of your technology?
Yeah, so GrAI Matter Labs is a fabless semiconductor startup in the general field of AI. And the mission of the company is what we call Life-Ready AI. So Life-Ready AI is really where we spearhead the next wave of AI applications. The first wave, as most of you know, really focused on understanding the world, generating inference data, which helped us, with keyword spotting in our smart devices, with face detection in our security cameras, with fast braking in our cars, basically metadata which is used by machines. The next wave of AI will really focus on us as the consumers, on all the devices in our homes, in our personal devices, in our cars, and bringing really the transformation of all the content, audio, video, others, which we consume in our lives professionally and personally, transform that with AI and get new experiences off the ground where AI is a really new inflection point. So that's really the mission of the company, providing full stack solutions, SoC, software, platform, services, all that for that. And the status of the technology today is that we have recently brought our second generation GrAI VIP chip to the market. We have received it in March from TSMC, 12 nanometer chip and wafer level package. We have brought it up, fully characterized it, and we are just started now to fulfill the backlog of about $1 million worth of pre-orders with a number of tier 1 companies which have been using our SDK so far, software preparations, and are switching that proof of concept work for their applications to the hardware side, supplying them with our hardware development kits, giving them the full chance to build out the experiences they look for in the next wave of AI, and then bring this in mass market to the market.
Excellent, excellent. So Mahesh, when you talk with potential customers and partners, how do you turn Life-Ready AI, which sounds good, and I love your graphics, how do you turn that into something material, something they can immediately grasp and remember? Do you have some examples you share with them?
Yeah, great question. So three things, right? So when we refer to Life-Ready AI, as you know, Carl, majority of the industry, a lot of suppliers out there tend to focus on TOPS and TOPS per watt and a lot of these metrics, right? For us, Life-Ready AI is about end user benefits, right? It is about what problems can we solve. So, Ingolf mentioned that we're working with customers, developing POCs, and literally not one of them has cared about what TOPS the processor offers or what's the TOPS for what. What they really care about is, of course, how are you going to solve the use case, right? What is the value you're going to provide them? What is the performance that we can offer? And key amongst that is, of course, the programmability, right? The ease of integration, when you have a chip that they can integrate into their products. So in that sense, the number 2 point, when it comes to Life-Ready AI, is that we look at providing a solution, right? It's not just a chip in that sense, right? So let's take the example of our dev kit, right? So we have a dev kit, which we call the hardware development kit. It comes with the chip, which is the GrAI VIP, but there's a development board that has a full host system with the Linux stack running on it. We've developed a full SDK. And the SDK is not just about the TensorFlow and Keras and the models that you can develop, but we ship it with a quick start library. So these are optimized models that they can take off the shelf, retrain. As you can imagine, most customers really don't care about the benchmarks. They want to take those models and apply it to their use cases. So of course, they need to be able to retrain it to their data sets. They need the tools that they're already familiar with. So that's something that we spent a lot of energy on. And really our target when we ship this SDK is that we'd like our users to be up and running within 10 minutes. Yeah, you open the box and within 10 minutes, you have this running and you can take a model from start and get it running, on your system, right? So you have that first experience within 10 minutes. So of course, this is not possible from just us, right? So we rely a lot on partnerships. So that's another piece of the Life-Ready AI, what we call the ecosystem, because there's only certain things that we can provide as Life-Ready AI. Customers have different sensors, interfaces, software, hardware that they have to integrate with. And so we have to rely on our partners and partnerships to kind of bring this all together. So as an example, we partnered with ADLink to develop our dev kits. We partnered with Framos from a camera. So we have something that's off the shelf, provides the capability for a depth camera or a single high resolution camera that they can connect to and test the algorithms with it. And of course, we had to do a number of partnerships to build a chip, like with ARM, with Synopsys, with iMac, and others. So I would summarize basically three things, right? Forget about tops or tops per watt. We focus on customers and solving their problems. 2, we want to give them a solution that they're up and running within 10 minutes. And 3, we are going to rely on partnerships to bring this all together. So that's Life-Ready AI.
That's cool. So I can't imagine the look on your engineer's face when you told them you wouldn't be able to drop this on somebody's desk and they can use it in 10 minutes. I mean, that's quite the accomplishment. Ingolf, from our previous conversations, you tried to explain where you're going with this. You talked about the current technology of providing near sensor understanding, as you mentioned just a moment ago, but also kind of where you're headed with high fidelity transformation. Can you share what you mean by that with our audience?
Yeah, so the near sensor understanding, let's say today's inference solutions, you can kind of maybe classify them by the power they consume. There's like the TinyMI world, TinyML world, is really prolific and is really all the solutions where some relatively small compute solution attaches to a relatively low resolution sensor, and they accomplish this together either in the sub-milliwatt or a couple of milliwatts, maybe up to 10, and they solve specific detection problems, across all these different devices in our life, in the industry and at home. And then maybe the exact opposite is like Edge AI. NVIDIA, the big incumbent there, solutions where you put one of these highly capable NVIDIA chips in a box, attach a couple of sensors like cameras via a cable, and then you look at maybe a power profile of about 5 to 30 watts, a fan, and really high throughput inference applications provided. And what we do is in the middle, we call it Endpoint AI. So we attach ourselves similar to NVIDIA to a high resolution sensor, anywhere from like VGA to 4K. So you get really the full experience of what you look at in resolution and, and color and everything. But we provide that very close to the sensor, attach ourselves in form factor and location very close to the sensor, especially also for very low latency. But we do that for like a couple of 100 milliwatts. So we provide really an unmet need, somewhere in the middle between TinyML and what current incumbents do, really attach very close to the sensor and serve, understanding-wise, very low latency solutions at the full resolution and capability of AI. The other term, the high quality transformation, So inference really focuses on metadata generation at high throughput, What really matters is like running networks like ResNet at really a given accuracy you need to achieve for the problem, And people have really ingenious solutions where they cramp many multiple accumulates, 8-bit int and so on the chip and achieve that. if in the next wave of AI, when we transform audio and video for consumption by us, yeah, we look at it again, yeah, well, we'll really expect the same high fidelity from audio and video. It's a completely different problem, yeah. Almost always when you interact with a human as technology, low latency is key. It has to be responsive immediately, seamless. So we provide that based on the brain-inspired technology. But the other key is we need to have a compute element architecture programming kit, which provides and maintains the high fidelity of the original audio and video input. And we do that by basically basing our architecture on 16-bit float. That makes a key difference in maintaining the quality of the original content as we transform it for the consumption in the new use case, as well as it makes it much easier to map the original software to our platform, because we basically maintain the original precision which people have been using when they created the application in TensorFlow. So these are really the two key points. We focus on something very close to the sensor and the power envelope from a couple of hundred to a watt, near sensor understanding, very efficient at really high resolution. And the other one is that we provide that low latency, high precision compute to maintain the fidelity of the content you want to consume. There's no compromise there.
Wow. And how much power does a high fidelity application consume?
Yeah.
Is that also in the hundreds of milliwatts, or I mean, that 16-bit float's a fairly energy intensive multiplication.
Yeah, so that's basically the magic of the brain-inspired compute, where we originally come from as a neuromorphic computing company, that we don't have the need to compute all the data which comes in via the sensors, but as an event-based compute engine, only the meaningful data which requires transformation. You know, it's not in the sensory data out there. There's sparsity in there on all naturally recorded signals, especially in audio and video, as we know from codecs, where you can compress audio and video data pretty much without any fidelity loss to, you know, a fraction of its original size. And we use the exactly same effect. We don't process only the events incoming from the audio and video data, and that relieves us from having to process nearly not 90%, so only the remaining 10%, and that is basically the basis of the compute efficiency and latency we have while maintaining that high precision. This is basically where this magic comes from, combined with the programming kit to realize and abstract that all the way from the user to the user. That's just a normal machine learning compute engine.
Interesting indeed. Mahesh, what kind of use cases can you share with us that your early potential customers and people looking at POCs, just a use case or two would help the audience to understand where this can be applied?
Yeah, sure. So, you know, just to add to what Ingolf was saying, of course, you know, use cases have direct implication on the power as well, right? So, you know, when we talk about hundreds of milliwatts, we're talking about higher frame rates, higher resolutions, right? So different users have different needs. So of course, when you're operating at 30 FPS or lower, you know, the power levels will be in the tens of milliwatts, right? So again, it's a function of what the use case is, what we're trying to do. Is it speech? Is it music? Is it, you know, different kinds of audio? So, you know, there's the whole plethora, but it was kind of like a marker in terms of, okay, where do we stand in terms of hundreds of milliwatts versus, you know, watts or microwatts, right? So yeah, I mean, to give you some examples, it was funny. So we were at AWE, we were talking to a bunch of our partners, and, you know, one of them, you know, is of course working on AR glasses. You know, you mentioned you have this wonderful experience in the VR space. You know, AR is of course, you know, as it takes it to the next step, where you're trying to, you know, embed both your virtual world along with the real world, right? And so you have to transform content, not only content that you already have pre-processed, but also new content that should come in, right? And essentially what, you know, we heard from our partners was indeed when they operated with 8-bit int and tried to improve quality and, you know, match the two worlds, it was far more easier to do this as 16-bit floating point rather than 8-bit int, right? Because the amount of trade-offs that they had to make that work was just a night and day difference. So they see a lot of benefits in use cases where you care about the quality of the content, right? The impact that you're going to have on the user. So that's one example. The other example, without kind of giving too much details from kind of our customer perspective, is what is interesting is, like, you know, if you look at the past decade or so, right? there's been like a plethora of applications. One key one amongst them is Instagram, right? So it's a social media platform, and it's kind of driven this hyper focus on visual elements, right? Essentially, how do you take pictures and transform them, right? And of course, it's been possible because of mobility and all these other things, right? What we're finding is that as this user engagement evolves, the focus is shifting not only from kind of these visual elements, but also in other sensors, example, audio, right? To offer like a truly transformative experience for the users. So we are currently working in the space, and we believe that we'll be able to offer at the edge the ability for users to craft a personalized experience that they've never had before. So kind of without giving too much away, think of it like the Insta audio that you could potentially share and experience in real time by yourself or your colleagues and your friends in real time. And really, in this case, this is where you care about the quality, you care about the latency, the flexibility, so that you can have this personalized experience. So these are kinds of the use cases which we are looking at.
Sounds good. Sounds good. So, Ingolf, back to you. What's the timeline? What's your roadmap look like, without disclosing too many details that you're not ready to disclose without an NDA? But just what kind of timeline? When should we be able to expect to see these devices in the real world?
Yeah, so it was a multi-step process for us. Yeah. So, there was an early step where we, proved everything in FPGA and made sure that, our original ideas how to apply brain-inspired neuromorphic technology to a fully digital domain, which is fully scalable, to something which, is fully TensorFlow programmable, and, can be really used at full precision towards these AI problems. Yeah. And then a bit more than 2 years ago, we've showed a first chip of the GrAI core, our compute IP, on a single piece of silicon, and basically work with customers to understand how they would use it and what their actual requirements would be for a real product. And so recently, as I said, we received the result of that engineering samples of a full SoC, which fully meets these customer requirements. And now we are basically in the process of fine-tuning that approach and the POCs with the customers, and then basically transform these engineering samples to be full market ready and roll that out in volume next year. That's so okay. Pretty close to the market already, and really ready for you to experience, and then to really bring this to millions of devices as a full commercial production version next year.
Cool. Yeah, I can't think of any other companies that are doing neuromorphic computing on the edge at that kind of precision in their roadmaps. I think you have a unique value proposition, and I think it's one the market will react very well to. So I'm sure you've got a lot of people waiting to get their hands on this.
Yeah, we received indeed a lot of visibility lately, a lot of awards, but most notably, really, people are really impressed by the demonstrations they have seen. Yeah, in the end, it's not about, again, PowerPoint tops or technology names like neuromorphic computing. Is about, you basically, and we have shown basically both. Publicly more on the robotic space already for a couple of shows in Europe, but you can see this in our office. All of you are invited to any of our offices, both here in San Jose in California, as well as somewhere in Europe, like in Paris, our headquarters. And then, of course, if you like, of course, then really live-ready AI for transforming audio in our offices as well. So yeah, to us, this is important.
That's what got my attention, is the demonstration you gave us to get Alberto and I on board as helping you guys communicate what you're doing. It was very impressive. I encourage the audience to look for those on the web, and there's more coming that you'll find even more impressive. Anything else as a wrap up here? We're about out of time, but is there anything else you'd like to talk about your vision for the company, the problems you're solving?
Yeah, so if you want to really remember what GrAI Metal Lab stands for, is really bringing brain-inspired technology to the next wave of AI, where really transform audio and video for us as consumers as we have this in our homes and our cars, at the workplace. The way we enable it is really, high precision processing enabled by brain-inspired technology, modeled by how the human actually, consumes that content. And then, really, if you want to think about a key use case and want to explore it, think of something like an Instagram for audio. Yeah, Instagram for images is a really killer application, and we want to bring to the world like Instagram for audio, and talk to us, and then maybe you can do something together.
Sounds good. Exciting. Well, thank you both for joining us today. I look forward to perhaps we can do this again sometime soon as you get some deployment started, and we can get back on the video and zoom about that when you're ready. That would be great. Yeah. We appreciate your time. Thank you all for watching, listening, and thank you, Mahesh and Ingal, for your time today. Stay well.
Yeah.
Thank you very much.
And look forward to do that soon. Thank you. Bye-bye to everybody.
Bye-bye.
See ya. Bye.